SSLFamilyDad with Simple Suburban Living, and today I want to talk a little bit about something that's kind of at the core of the whole aquaponics ecosystem, and that's the nitrifying bacteria. So these are the little guys that work throughout an aquaponics system to get rid of the bad stuff and make the good stuff. They basically take the waste from the fish, turn it into something that's non-threatening to the fish and good for the plants. There's a lot of information to cover with this topic, so I'm going to try to keep this video as short as possible, but I don't want to skip anything or rush through anything. This video might get a little bit longer, and I apologize about that. The two main topics I'm going to cover are kind of the two types of bacteria, what they do in the system, just because I find that interesting, and also kind of what the optimal conditions are, where pH and temperature-wise that they live the best in your system, so you can kind of keep an eye on that. When you're wondering why you have nitrite or nitrate spikes or ammonia spikes and different things going on, you can kind of look at these factors and say, okay, what's happening with the bacteria colony? Did I kill them all, or what happened? So I'll kind of talk about that. The second thing I want to talk about is biological surface area, which is basically how much grow media you need in the system, or some type of biomaterial, basically surface area for the bacteria to grow. How much of that you need per how many gallons of water and how many pounds of fish and all that kind of good stuff, because that's something a lot of people want to know. We'll get into it here and kind of break this down into those parts. So the aquaponics system basically works on the nitrogen cycle that the goldfish produce the ammonia and ammonium through their waste and the breathing process and uneaten fish food and other types of materials that break down in the system. They produce ammonia and ammonium. The first bacteria that come into play are called Nitrosomonas, and Nitrosomonas is a category of bacteria. There are several species in that category that live in different types of environments, whether you're talking about salt water or soil or fresh water. But this category of bacteria, they work on the oxidation of the ammonia and ammonium. So they take that and they convert it into nitrite. Nitrate is actually kind of poisonous for fish if it's not kept at a low level, and so the nitrite, you want to get that converted into nitrate as soon as possible, which is where the second type of bacteria comes in. But first I'll talk about kind of where the Nitrosomonas bacteria, the best range for them to live in. Excuse me. So this type of bacteria kind of tends to like a higher pH. So again, the optimal pH range for this bacteria is between 7.8 and 8. Now, most people are not going to run their systems that high. Unfortunately, my system is still at about 8, and it's actually been coming down if you followed along with any of my other videos. So these bacteria are doing great, but normally you want to run a system between 6 and 7, usually between 6.5 and 7 is where I like to keep mine. And so that doesn't mean that these bacteria aren't going to live or grow at that point. This is just like their perfect, environment for them. They will work just fine at 7 and 6.5. Now it does say in some of the research that I did, if your system drops below 6.5 in pH, that these bacteria are starting to get kind of severely inhibited. So you may have less of the bacteria. Your conversion process might get a little bit slower. You won't be able to have quite as many fish in a smaller area. So something that you need to consider when you're trying to choose where to keep your pH at. So again, Nitrosomonas converts ammonia or ammonium into nitrite, which is NO2. So moving on to the next type of bacteria, it's called Nitrobacter or Nitrobacter. It is another kind of family of bacteria. There are several different subspecies that work in different environments. This bacteria works on the oxidation of the nitrate. So it takes and eats up all that nitrite and converts it into nitrate. Nitrate is what we're looking for in the aquaponics system. Obviously, that's what the plants use, the nitrogen fertilizer kind of thing. That's what the plants can readily uptake and use for growth. So the Nitrobacter, again, it is converting nitrite into nitrate, and the pH range that this is, again, optimal for is 7.3 to 7.5. That's like the perfect sweet spot for this bacteria to grow and flourish. And be most efficient at its conversion, which is what it's there for. It's also worth noting that this type of bacteria is less tolerant to colder temperatures and higher pH. So again, most systems are going to be running at a lower pH, so you don't have to worry about the high pH thing generally, but if you accidentally like dumped a bunch of calcium carbonates or something in your system and your pH spikes up to, I don't know, 12 or some crazy number, 9 or 10 or whatever, then you might actually, you could kill these bacteria or they won't work at all. You'd have problems with nitrite and other things, so something to keep in mind. Nitrate is NO3. So these two families of bacteria, you need both of them in your system. For anyone just starting off with aquaponics, you don't need to put them in there. They will find their way and start growing. I don't know where they come from. They're in the air, or they're on the rock, or they're in the water naturally in the environment, and they will start to breed and multiply given the right conditions. So you don't need to put anything in the system, just start running it, put some fish in there, and some surface area for these to grow on, and they'll start growing. So that's kind of the general overview of the two types of bacteria. Now I will talk about temperatures, which is another thing that aquaponics, if you're building a system, running a system, you need to know. Do I keep my system high or low? Your fish might have certain requirements. Some type of tilapia like hotter temperatures, some type of tilapia like blue tilapia will take colder temperatures. Goldfish, they pretty much don't care. In fact, we had a friend who had a goldfish in an outside goldfish pond, and it froze solid. With like this much water at the bottom, and we just pulled the fish out of it and put it in our system. It was still alive, so they can pretty much handle anything. So don't worry about goldfish, but other fish do need different temperatures, and so you want to kind of take into account also the nitrifying bacteria. You don't want to go too high or too low. Now generally with the nitrifying bacteria, too high is better than too low. 77 to 86 degrees Fahrenheit, which is 25 to 30 degrees Celsius, that's kind of your optimum temperature range for the bacteria. Most people are not running their systems that warm, I don't believe. I don't run my system that warm, so they're not running at their peak efficiency, but that's okay. It is worth noting from the research that I did that if your system is 64 degrees or around that temperature, the bacteria are going to operate about 50% of their total efficiency. And if you get below 46 degrees, or between 46 and 50 degrees, they're working at 75% of less efficient. So you want to keep, and I have a small heater in my system. I keep my system between 70 and 75 just to kind of keep it, right now I think it's at 69. I just have a new heater put in. But that's a good range, I think, for the, kind of a sweet spot for the fish and the plants and everything else is about 70, 75 degrees. It's not quite into this optimal range, but it's pretty good. So that's kind of the rundown on the two types of bacteria that we have in an aquaponics system, and kind of the ranges that they like. I think the hardest thing to kind of figure out when you're starting the system is the pull pH thing, and once you get your pH running between 6.5 and 7, and you have enough surface area for the bacteria to grow on, even if they're running at, say, 75% of their maximum efficiency, or even 50% of their maximum efficiency, if you have enough surface area for them to grow on, you can still support quite a few pounds of fish in a system. Smaller systems even, you can still support a good colony of fish with, even when the conditions aren't perfect. So don't worry too much about it, but you do want to keep this in mind if you're having problems with nitrite spikes or nitrate spikes or ammonia spikes, and you're kind of trying to figure out what's going on. Lastly, I'll say that if you're starting a new system, it does take a little bit of time for these bacteria colonies to kind of ramp up and get built up and get settled in. They're also sensitive to light and things like that, and so you don't want to, if you're constantly stirring up the grow media and moving things around, they won't, you'll kill a lot of the bacteria that way. So it's best to let things sit, let things cycle for a few months before you're going to be at your peak efficiency in your system. So I'll actually move on and talk a little about the surface area of the biological material that you're using, whether it's rock of some sort or hydroton or some other type of media, and kind of how much you need for your system and how many fish you can support and things like that. So I'll get some new notes put up here and we'll talk a little about that. Alright, next we're going to talk a little bit about biological surface area in your system and how much you need. This is very important and kind of at the core of an aquaponics system design. When you're setting up your system, you need to know exactly how much grow media that you need to have in order to support, however many pounds of fish and how big your aquariums are, your tanks and all that good stuff. So this is very important to kind of sit down and figure out before you go and build a system. So I'm going to talk about a few different things here. We're going to talk about this, the biological surface area in terms of square feet. So what we're talking about is if you were to take a piece of your grow media and add up every little flat spot on it, you'd have a total square foot surface area on each piece of grow media. Now if you took a cubic foot sized box and filled it with your grow media and added that up, that would give you the total square feet of surface area on all the rock in 1 cubic foot of whatever your grow media is. Then you could use that to figure out how much total square feet of surface area you have, throughout how many grow beds you have. I'm using what's called beechwood pebbles here. This is very similar in size to like a river rock or maybe a small lava rock or something like that, like a crushed stone. These are bigger than hydroton or the clay, baked clay. These have a very good and high surface area, especially because of the way that they're kind of misshapen and they sit together. They don't come up against each other, or they're not flat, so they're not hiding each other's surface area and that. So this is a very good, what I found to be a very good choice, as well as other types of misshapen rock. So the calculations I'm using here are based on my beechwood pebbles, again, very similar to like a river rock. So the first thing we need to do when we're trying to set up a system is just kind of figure out how many fish you want to have. You'll need to do some research on that, what type of fish you're going to have, how many fish you can have per gallon of water, just depends on the type of fish and all that kind of good stuff. You need to figure out how many fish you're going to want to have, and that will help you determine how big of a system you want to have, how many gallons of water, how big your tanks need to be, and all that stuff. Once you have a total number of gallons of water in your system, then you can kind of figure out how big your grow beds need to be. And so there's two kind of main calculations that we need to do. First, we need to figure out how many square feet of surface area we need in our system total. And you can do that two different ways. The minimum that you need to have is about 2.5 square feet of surface area per gallon, every gallon of water in your system. So figure out how many total gallons of water you have, multiply that times 2.5, and that will give you the total number of square feet of surface area that you need for grow media in your system. Now you need to convert that into something that we can understand, like how much. So, okay, let's say I had 200 square feet. How much is in one of these grow beds? I have half of 55-gallon drums here, so I need to figure out how much square footage is in each one of these beds. So I need to convert that to a volume first. So I figured out here that 55-gallon drum contains about 7.35 cubic feet of the grow media. In my specific case, you can go online and look up the specific surface area of whatever type of grow media you have. The beechwood pebbles are about 50 square feet per cubic foot. All right. So every cube size, cubic foot of a grow media that I have in here, I have 50 square feet of surface area on my rock. So I can take that and multiply it and figure out how much square feet I have per 55-gallon drum. Now each one of my grow beds are half of a drum, so I would obviously split that in half and figure out how many of these grow beds I needed to support whatever size system I have to meet this 2.5 square feet per gallon of water. So I know it's a little bit confusing, and we'll talk about another way to go through this as well. And just to note, you can look this up online, but every gallon, so if you're using an IBC tote or some other type of tote for a grow bed, every gallon of water that it holds, or every gallon that it is 0.134 cubic feet. So you can help kind of figure out how many cubic feet you have in a given type of grow bed that way. So another way to figure this out and to make sure that you have enough surface area in your system is by going by the number of pounds of fish that you're going to have, and that's adult fish poundage. So if you have a blue tilapia that's going to grow up to be a pound at harvest time or whatever, that's the number you want to go by at the maximum weight of the fish. So then you say, okay, I can have 10 fish, or I want 10 fish. How many grow beds am I going to need to support that? And this works out to about 100 square feet of area of biological surface area to support 1 pound of fish. So for every pound of fish you're going to have, you need 100 square feet of surface area in the system for the bacteria to grow in order to process the waste that fish is going to produce, turn it into something good for your plants to grow. I like this conversion a lot better than the water, because the amount of water you have in your system isn't as important as the pound of fish that you have. That's the most work, because they're the waste producers. So using that, you can figure out how many square feet of surface area you need, and again, you can use the calculations down here. The specific surface area is 50 for my beechwood pebbles per cubic foot, and then I can use that to figure out how many cubic feet of space that I'll need. And then if every 55-gallon drum has 7.35 cubic feet, then I can divide that out and figure out, okay, I need 3 or 4 or 2 of these, grow beds, or whatever size grow bed you're using, in order to support that. So now, we talked a little bit earlier about the nitrifying bacteria and the different variables that are at play, whether the nitrifying bacteria are going to be at their optimum efficiency with temperatures and pHs and stuff like that. So if your system's really running good and you've got everything running well, you can probably go up to about 1 pound of fish for every cubic feet, just kind of a direct correlation here. 1 pound of fish for every cubic foot of grow media that you have in your system. And that's for, something like this type of grow media. So 1 pound of fish for every cubic foot of grow media that you have. So calculating on the fly here, if I had about 7.35, so in my system here I've got about 15 square feet of grow bed space, or whatever you want to call it. 15 square feet of grow media in my system. So with this I could probably support about 15 pounds of fish. 15 blue tilapia, if I don't know what their adult weight is, I'm just guessing. Let's say they're 1 pound, then I could have 15 blue tilapia in my system. I've got over 110 gallons of water here, so that's fine. And so that tells me what I can support. Now, there's a learning curve. If your bacteria county isn't established, it takes a few months for that to establish. So you don't want to just go and throw 15 blue tilapia in your system, after you've done your calculations right when you start off, because it might take a few months before the nitrifying bacteria are at their full capacity. And there's a lot of factors that come into play there. So you want to run the system for a while, make sure everything's running well, then put your fish in, your final fish. That's why I've used goldfish here. I will be hopefully getting tilapia in my system this winter, depending on suppliers that I can find for them. But this is kind of the similar type of system that I used when I tried to figure this system out. Again, you can never have too much grow media. So if you want to have 15 grow beds in here, that's fine. As long as you have, in that case, you might need to get more fish, right? So if you want to have more fish, raise more fish in a smaller area, then more grow beds, more biological material in your system is going to make it more efficient. So hopefully, and before I want to also know, no matter what type of biological material you're using, that nitrifying bacteria has to have oxygen in order to grow. And I didn't mention that earlier, I wanted to mention that. I'm using flood and drain, so the water level is constantly draining and flooding and draining and flooding. That gives a lot of oxygen into the bacteria, so that gives them a very healthy environment to grow. There's other types of biofilters where you have to use bubblers or venturis or other types, so you have to get air in there, so that because it's called oxidation. That's what the bacteria is doing. It's oxidizing the ammonia into other things. It needs oxygen, so it's very important to have good aeration in your system in order to support the bacteria. So the better aeration, better oxygenated your water is, the more efficient the bacteria are going to be as well. And again, you can start to push the limits of how many fish you can have per grow bed or per biomaterial surface area. So I know it's kind of confusing. Hopefully I did a decent job of explaining the basics, but again, you really need to kind of go through this when you're designing a system, or if you want to add on to the system or figure out how many fish you can get. And also a good test kit, so you can constantly test the system when you're adding more fish to it, or adding more grow media, and you can kind of figure out that way too by trial and error a little bit. All right, I have a nitrate, so my nitrates are always high, so, and ammonia is always high. They should really be at 0. If you test your water 3, 4, or 5 hours after you feed your fish, ammonia and nitrate, there shouldn't be any in your water. it should all be converted to nitrate if your bacteria are growing and working the way they need. If it's not, then you need to look at those factors that we talked about at the beginning, or maybe you need more surface area. You need more bacteria. Maybe your bacteria can only work at 50% efficiency because of the temperature of your water and the pH of your water. So then you need more bacteria, right? So that's another way to solve that problem. So testing your water frequently is a good way to figure this out as well. So hopefully I helped you and didn't scare you away from aquaponics if you're looking into it. This stuff is actually pretty simple once you kind of figure it out. Hopefully I helped kind of shed some light on it. This is stuff I always find interesting, and so I always like to do these kind of talks over a topic that I find interesting. Hopefully the video is not too long. I do apologize if it is. If you stuck through to the end, I appreciate that. Hit thumbs up on the video. I always appreciate a thumbs up. It makes it's very important to our YouTube channel, YouTube videos. If you liked it, to hit thumbs up. If you didn't like it, you don't have to hit thumbs up. But we appreciate you watching. As always, please throw your questions below. Check out the blog post that corresponds with this video as well. And I usually have more information. I'll put some of these numbers and calculations over there at the blog. So check it out if you have a minute. And as always, I really appreciate you watching. Have a good one.